Is this thing on?
It's on.
All right, here we go. Boy, I can hear every little mouse click you make. Sorry. All right, here we go.
I'm gonna mute myself.
Okay, here we go. Oops, sorry. Hey, hi, hello, and welcome to the Radio Tech Guys podcast. It's a pleasure to have you with us. I'm just gonna let the play.
Oh, I'll edit this part out and then tighten this up.
Why? This is gold. This is gold. Hey, hi, welcome. Very glad to have you with us. My name is Alex Linger, and on the other side of my computer screen, in an undisclosed location, we'll say, is Chris Moran. Hello, Chris.
Oh, hello, sir. How are you?
Oh, I'm doing fine, thank you. And yourself?
I'm doing well. I apologize for the headphones and also the built-in microphone sound.
I think the headphones are fantastic.
Mm-hmm. This is what I said. I'm mailing it in already. We're in episode 20, and it's I'm mailing it in.
I think these shows hit a speed bump right around this time, and as long as we break through, then greener pastures ahead. I guess is that.
We'll keep working towards it.
Well, let's see. What do we normally do? Oh, first, okay, how you can get a hold of us, and we want to thank you. We've had some emails come in. We're going to talk about one of those tonight. You can email us at ask@theradiotechguys.com, which is the primary mode of communicado. You can also get to us with some social media outlets. Yes?
Absolutely. We'd love for you to do that. We're on Twitter. You can find us by searching Twitter, our hashtag, or not our hashtag. What am I saying? We're on Twitter. It's just Radio Tech Guys on Twitter. No the.
That is right.
And also search for us on Facebook, the Radio Tech Guys, and YouTube. Subscribe to our YouTube channel, where there is actually some content that we've created since the last podcast episode. It was some drone activity looking at a tower, which is kind of interesting. I thought I learned some things we would do differently probably next time.
So that's going to be a big thing, right? These tower inspections.
I would think so. I think the one that we use specifically is a fairly old. I mean, that's a 4 or 5 year old drone, and the camera on it, frankly, it's just a GoPro 4 that I had modified the lens. It didn't have a stock lens anymore. It had a
you got rid of that fisheye effect, right?
I did. So it had a little bit of a tighter lens, but the problem with this lens is I also focused it for the way I normally use the drone, which is way further away, more distant stuff. And so it doesn't have the luxury of those GoPro stock lenses of having such a wide focal plane. So some of the stuff we noticed as we got close to the tower, is not, the focus isn't tack sharp. So, there's newer stuff out there, newer, way better drones. That technology is just coming on so fast. So we'll have to do it again with a better drone to see what some of those pictures could really look like. But I would definitely think that's a thing.
Oh, yeah. Yeah, I mean, I would imagine, when it comes to tower inspectors, we are certainly amateurs. But I think that'll be a thing even for the professional crews. I mean, how much faster and cheaper is that for them to take a quick look? That by no means does that take the place of an on the tower inspection, but you can certainly see what you're getting into before.
Right. And in cases where you might think there's a risk putting a person on the structure, you could get up and get a look at things before deciding to send a climber. So I definitely think there's value in it. Maybe not exactly in our methodology or the stuff that we took. I don't know. We haven't heard back from the crew we sent the photos to about whether they gained anything from it, but it was a neat experiment. I think there's uses for it even in our application.
Yeah, I mean, anytime you can get eyes up there, I mean, regardless of the method. But we'll talk a little bit more about that a little bit later in the show. We'll talk about why we were doing that. There was a reason. We want to talk briefly about audio over IP, which, okay, have we talked about that before? Absolutely. Have we talked about it more than once? Absolutely. Will we talk about it again? You better believe it. But obviously, that's a big topic for your standard broadcast facility. We want to talk a little bit about some of the methodology and the protocols that are being used. And we'll also talk a little bit about the terminology. When we say audio over IP, I think there are two very distinct ways that you can use that term. There's the term that we typically use. No, I misspoke. There's the way we typically use that term, talking about linear audio on a LAN, in a closed LAN environment, basically just replacing the old analog shipping cables that you'd use in your studio. Well, then there's audio over IP in the sense of maybe remote broadcasts. If you have a Comrex access that's plugged into the internet, technically that is audio over IP. It's audio being shipped across internet protocol. So absolutely that term works in that way as well. In this show today, anyway, we're talking about audio on your LAN and the different protocols, the different languages that some of this equipment speaks. So as you know, we are an Axia plant. Almost all of our sites now are Axia plants. We do have a Wheatstone environment, so we have a little bit of working knowledge in that as well. Very little, but these manufacturers, I guess it sort of had to be this way early on, but they kind of painted themselves into a corner by creating what's the word I'm looking for? Proprietary.
Yeah, proprietary.
Couldn't pull that one out. These proprietary languages that only their equipment spoke. So in the Axia world, it's Livewire. In the Wheatstone world, it's Wheatnet. And there's lots of other ones. There's QLAN from QSC. There's Ravenna. There's Dante. Well, now, new player to the game, there's an open standard called AES 67. And the idea behind AES 67 is we can bring all of these proprietary languages together. They still don't necessarily directly talk to each other, but they can use this AES 67 protocol to communicate. Well, as you can imagine, that opens up a whole good can of worms. Maybe you're an Axia facility, maybe you're an Axia plant, but you really like this audio over IP piece of gear that some manufacturer makes. Well, before, you were kind of out of luck because you had to use whatever Telos manufactured. But that's not true now. With the advent of Livewire Plus, now Axia speaks AES 67 and Ravenna as well. So there are lots of, well, I shouldn't say lots. There are more and more manufacturers creating AES 67 gear. Genelec came out with a set of speakers that just has an Ethernet jack on it. That's it.
That's so cool.
It's super cool. And we'll talk about even more why in a second. Neumann did the exact same thing. Now, that's hard to wrap my head around, to think about seeing an Ethernet cable coming out of the back of your microphone and that being acceptable. But it is. And if anybody can do it and make it worth something, it's probably Neumann. I mean, you're not going to question what they've
already good mics. If they're building good preamps and then good A to D converters,
exactly.
That's really the magic of it, I think, right there. And then if you're just shipping it around in some IP form, it doesn't matter what that is. But
exactly.
I think that's really cool to build that all into the same small piece of hardware and then just plug it in.
Yeah, exactly. And like you said, A to D conversion. With a microphone, you're always going to have to do A to D conversion because your voice is analog. You just, there's no way around that. But to keep it in that single piece of hardware, you're not making a connection out to an audio processor or something like that then has to make the conversion. there are lots of benefits. There are just lots of benefits. So there's a good place for an edit because I literally forgot where I was going with that. I am going somewhere with that. Make a little note.
Thanks. Hello, YouTube audience. Enjoy this behind the scenes look at the inner workings of Alex mind.
Behind the scenes.
You were talking about devices, more devices.
Pull up my list here.
Becoming, AES-67 devices or devices that can talk on these networks.
Yeah. Yep. Okay.
So you said so.
Thank you. I appreciate that. All right. Let's see here. We'll just take this YouTube video down. I should have read ahead. So, as you can imagine, like I said, that's a huge gain to be able to bring in other manufacturers' devices. Now, do I think that if you're an Axia plant, you're going to make a Wheatstone blade talk to a power station? No. In my opinion, that's never going to happen. But these sort of, I'm going to call them third-party manufacturers, because in my opinion, and people will dispute me on this, I'm sure, but in my opinion, if you're building an audio over IP infrastructure in your facility, it's either going to be Axia or Wheatstone. I'm sorry. I know there are other players. I know that there are. But let's face it, those are the two champions on top, I think. It's just how it is. But you now have the ability to sort of piecemeal your system together a bit more. Yamaha uses Dante. They have a whole line of products that are Dante enabled. And technically speaking, I don't know why you'd want to, but if you wanted to use Yamaha consoles in your radio studio, you could. You absolutely could.
That was really my first taste of IP audio, honestly, was in the live sound reinforcement world when I worked at it's a mega church, just call it what it is, in a huge auditorium setting, where we had 30 or 40 amplifiers that drove our main PA in the auditorium, and we had 3 system controllers, 3 PA controllers, and they all talked Dante. And that was really new to me at that point. I mean, I guess it wasn't my first experience. We had done a couple IP studios before, but really seeing it integrated in the live performance space was pretty cool.
All right, here's a question for you, and I don't know the answer to this. Where did audio over IP really flourish first? Was it in the broadcast world, or was it in live audio?
I'm going to have to look into that. I think it was probably in live audio, honestly.
I think you're right.
On a limited scale, like not like it is today, where they're doing like where you can put the days of the way we used to do like audio snakes are over, because most of the console manufacturers today are building these stage boxes with all of your mic preamps in them. And then it's just an IP connection from there, hauling everything back and forth between there and your front of house console and monitor console, recording whatever, however you're delivering it. But how cool is that? Think about that for a minute. In the old days, you used to have these gigantic transformer isolated stage boxes. So if you had, you had a lead vocal mic that came into this thing, and then that box split off 3 ways sometimes, or 4. Sometimes it would go to 2 front of house consoles, a main and a backup, a monitor console, and a recording console. So you would have to take that analog source and split it 4 ways. Well, once you've created these IP audio streams today with these digital stage boxes, then it's just a digital signal. It's just IP. You send it as many places as you want to send it easily, and it's all routable. It's all mouse clicks now. There's no more patching or any of that craziness.
Exactly. And that is also something, as you're researching technologies, and maybe we're getting a little bit out of the radio world for a minute, but that's okay. As you're researching technologies, none of them work exactly the same. they're all very similar, but none of them have exactly the same characteristics in how they speak. For example, I can really only speak to Livewire. I don't know about how Dante works enough, but Livewire uses a true multicast so that if you have a source, that source can be available anywhere on your network. Anybody can subscribe to that source and have that audio. Not all the other protocols talk like that. Some of them have subscription limits, and they create an individualized stream, not necessarily unicast, but I guess in a sense it is. They create a stream specifically for the receive side. So that's something you sort of have to think about. But like I said, Livewire, WheatNet, in the radio world, those both work the same way and create a multicast stream that you can use everywhere on your LAN. So we throw around the term AES-67, and we don't just throw that around because that actually is the term for this open standard. But a lot of us are familiar when we hear the term AES, we think about, the old AES EBU cabling that is still used today. You probably have CD players or really any number of devices in your studio that are AES compatible. When you think about that, you think about an XLR connector that's carrying that AES, that digital signal. AES-67 basically is just that. It is just that AES signal. However, it's carried over Ethernet and carried across a network, and that gives you a distinct advantage because that Ethernet cable doesn't just do audio. You carry those audio packets, but you can also carry your TCP packets, UDP packets, whatever that device needs. So, for example, the Genelec speakers that we talked about, all there is an Ethernet jack. There's no LCD screen on the front. There are no controls. So you have to talk to those speakers somehow. So Genelec has software that you run that discovers them. I think it uses Bonjour. I should also mention most of these protocols use Bonjour to discover other devices on the network. I believe that's how Genelec does it as well. And you run this piece of software to adjust EQ and volume and all that kind of good stuff all across that AES cable that used to just be for audio, but now it works for data.
Yeah, pretty cool.
Super cool. That's super cool. Like I said, I'm sure we'll talk about this more later in other episodes because there will be more episodes.
I think, yes, there will. I think that integration is really key, though, that open source standard. If you really want to get manufacturers to play well, Telos has had a distinct advantage in the market in terms of their Livewire protocol that they developed because they were already making other devices that broadcasters use, like phone hybrids and remote equipment and processors in the Telos Alliance family of companies there. And so they had a built-in kind of infrastructure is not the word I'm looking for, ecosystem of broadcast products that used their standard. And so there was an advantage to that. But I do think to get all these players, like how cool would it be if Comrex, or, that's just an example, pick any manufacturer that makes box gear that we use for various things.
Sure.
There was a standard where regardless of if you had a Livewire network or a WheatNet system or whatever you were using in your facility, that you could bring in and know that this is going to work in your audio over IP environment. So I think it's important. I think that's why the industry, I think, is embracing that moving forward and working towards an open source standard. So things are interoperable.
Yeah. Yeah. And I don't think it's a bad thing necessarily that they have created these proprietary languages because, okay, I'll equate this to like Windows versus Mac. The reason that people think that Macintosh never breaks and always works, and that is far less true today than it used to be, but that's a different show, is because Apple manufactures the hardware and the OS, and the majority of the software you run on it. They control everything. Windows is at a disadvantage because Microsoft, I guess they do, but typically they don't make the hardware. They make the software, but not the hardware. So I don't think it's a bad thing that Telos makes the hardware, they make the software, and if that's all you need, if all you need is their products, it runs wonderfully. You don't have to worry about it. But now you have these little tunnels available, these little openings available to bring in other hardware without the risk of wrecking the rest of your network. So no, I don't think it's a bad thing that we're kind of proprietarily, whatever.
Yeah, I'd go with that.
Sectioned off in these manufacturers because, like I said, if that's all you need, it's going to work very, very well. But yeah, open standards is always a good thing. Open source software is a good thing. It's all good. But yeah, it's a good direction we're going, and I think as the future goes, we'll see more and more of this ability between the manufacturers to talk and play nicely, and that just opens up possibilities for you, the consumer.
Yep, absolutely. Very cool.
So that's all we'll talk about with that. But okay, so we talked about this drone flight. Why were we doing it?
Well, so yeah, let's go back to this project. We've been talking a lot on these podcast episodes about the tower reinforcement project that we're doing on one of our structures. It's a 420-foot tower built in 1981. It currently houses a 6-bay FM and a myriad of other accessory devices, 950 STL dishes, a couple 11 gig and 24 gig equipment. And we needed to put we got one of these, we were putting a translator on for one of our AMs on FM here in Morgantown. And we had to put up a 6-bay Shively antenna. It's a lightweight antenna, but because of the directional pattern it was required, it ended up being 6 bays. And so we decided that before we just jumped in and started throwing more stuff on this structure, we probably ought to have a structural analysis completed. And we did that, and we found,
thank God we did.
Yeah, there were some definite reinforcement things that had to be done. Some steel belly bands needed added. One level of guy wires needed completely replaced, and whatever. So,
and don't forget, not only do we have stuff on this tower and we're adding weight, but this is also an older structure. So
yeah, it was built on previous standards. But this is we put this job out to bid and got some bids back, and then awarded this contract to a tower company. And part of their due diligence before they start work is to come, and before they actually even order the steel components, is to come out and do a pre-measurement kind of site visit, just to take a look at things, make sure that the steel that they're going to order is correct, because we don't want to be reordering hardware for this job. And they just want to generally get a feel for the structure before they, before they climb it and work on it. And so they came in and looked at the tower. They dug up a couple of feet of anchor rod at each of the 6 anchor points, and found a handful of issues. In fact, we didn't even end up finishing that pre-measurement inspection because of some of the issues that they found. There's definitely a guy anchor, one of the inner anchors, that has some corrosion that is, in the magnitude of an inch or more of missing steel from one of these rods, and that's just a couple feet into the anchor rod.
Not a shocker, because this one sits in a spring.
Basically in a natural spring, yeah.
Water all the time.
Exactly. It's basically wet around the clock. And then there were some other things, the lower guy wires that were original to this structure from 1981 that are corroded. There was one pull-off in particular at like the 3rd guy level, one of the, the preform type pull-offs that definitely was worn and needed to be replaced. So, there were some things. This led us down a really terrible rabbit hole, because here the predicament that we find ourselves in is that we've already bought the translator hardware and its antenna. Everything is sitting in a garage in Morgantown waiting to be deployed. We've bought the license. We've signed the contract to do the reinforcement work that now we cannot do until we figure out what more needs done. And so what the hole we headed down was the tower company basically said, you know, we need to inspect all of these anchors before we can move forward. We want to make sure, you know, if we found one that's bad, there may be other problems. And so the first thing was we want to dig up all 6 anchors, put in temporary anchors one at a time and dig them up. And that'll cost, you know,
don't worry, that's cheap.
No problem. $12,000 to $20,000 per anchor. You know, okay, great. That's not reasonable. I mean, that's just not
not in our scope of work here.
That's not going to be manageable. And so that we were a little bit panicked about that. In fact, we hope, but it led us to a really cool discovery through this company, in that there's a group that's doing it is ultrasound by definition, but it's not the way we normally think of ultrasound, like where you would take a device above the earth, move it in over top of where the anchor rod is, and then try to penetrate the earth to see what is below. What they're doing is they have some hardware and software that they're using where they actually clamp onto the exposed guy anchor rod above the earth, attached to it, and they're able to send various frequencies sonically down through the rod, and then based on, I guess, how it resonates and what returns, they can paint a pretty good picture of the shape of that guy anchor at a much greater reduced cost than, you know, excavating is just mind-numbingly expensive. So we've signed a contract with them. We're waiting on a date that they're coming. We're going to talk to them ahead of time about documenting this project as much as they'll let us. I don't know, you know, there may be some restrictions on what we can show or whatnot, but we definitely want to show you guys what this looks like, because we're pretty excited about it. This could be big, because we have a lot of old towers, frankly, that probably will need looked at over the coming years. So that's upcoming. The other thing that's cool is we completed our pattern study. We're also in this, since we're working so much on this tower, we're going to replace a 36-year-old FM 6-bay ERI rototiller antenna with a new ERI rototiller antenna and transmission lines, 3-inch Heliax pressured transmission line that's been there since 1981. So that's pretty exciting. And we actually we're talking. We got an email this week from Philip, who asked. He was asking about this antenna replacement. The station that we're replacing, their primary FM antenna, is a 50 kilowatt ERP, top 40 radio station, ratings leader. You know, book after book after book, and has been so really since it signed on the air. Monster signal. But Philip had asked a pretty good question I thought was kind of interesting. He said, I recently heard you talk about replacing an antenna with the same size but newer antenna and getting better performance. I too have a 20-plus-year-old antenna that I suspect isn't performing as well as it should. I get multipath in areas I don't think I should. So my question is, how do you pitch a new antenna on a hunch? And in your case, what do you think it is about the 20-year-old antenna that caused it to underperform? Degraded metal, bad connectors? I'd like to get your thoughts on this.
It's almost like he understands how it is to get approval for big projects.
Exactly. And this is one of those voodoo things. Like, signal performance is just such a subjective. It's such a subjective thing. You know, we've had our share of phone calls from our boss, who's the president of the company, just, you know, kind of losing it about signals at various times. There are times when it's been absolutely correct because of we found things that had to do with our solid state. I mean, our tube final transmitter that we have complained about on here before. As the tube starts to soften, we're running, you know, HD at high injection power on that station, and we have some self-interference problems that kind of manifest as multipath to the listener, and so it's the effect is you think there's something wrong with the signal, which I guess technically there is, but but then there's other times where there's absolutely nothing wrong, and that is the signal. The other problem that we just can't seem to wrap our minds around is what the FM noise floor looks like today versus what it looked like in 1981.
Correct. Yep.
There is just so much more noise. There is so much more noise in the FM, well, in all these bands, just because we've completely just eaten away at the protections that we used to offer to FMs. LPFM was a big part of that, and now all these translators that are coming everywhere, and not just that. I mean, there's so much RF. So that plays a part in how people perceive signals. But directly to answer your question, in our case, we are at the same time kind of fortunate that our executive management and our president is also, I mean, he's a engineering-minded person. So he's been saying for years, we really need to replace this antenna. Yeah. We did one a couple years ago. It wasn't exactly apples to apples because this wasn't an ERI rototiller coming down. This was a much less nice antenna that had been retuned at least once in its lifetime. But we replaced that antenna a couple years ago, and it was honestly, I can't even tell you, it was night and day, just in terms of the performance in where it was supposed to cover, but also getting back to how it, how it was supposed to be originally when it was put on the air.
We actually wondered if we were still legal after we changed that antenna.
Yeah, we double checked. The gain numbers are correct when we are legal. We were just underperforming really because of whatever the antenna is. So here's what I think happens. Again, we've disclaimed on this podcast that we don't claim to be the end-all, know-all parts of this. But the way I theorize about these antennas is I think two things. First, we know this specific antenna in question that we're taking down, that's been in there since 1981, was taken off this tower once before because someone thought we had a problem with it. And in the process of putting it back up, the bottom bay, the bottom bay, it's a bottom fed antenna. The sixth bay was dropped from about 50 feet off the tower, broke, and taken to a local machine shop where they welded the element back together. Okay, and so we have pictures currently, even of its current state. It's not exactly plumb, and there's some things with that bottom bay.
What could possibly go wrong?
Well, you know how the harmonics, the mathematics work, the base spacing. I mean, that stuff matters. So we already know that there's something there to that.
Well, not to interrupt you too much, but I'm going to. So you got this pattern study done for this new antenna. That was eye-opening to me because I never had a good understanding of, I mean, you move this thing a few degrees one way or the other, and that the pattern changes drastically.
Yeah, it's hard to wrap your head around the idea that these antennas like this one that we're looking at are in theory, they're omnidirectional. So if you put them in space, if it was just the antenna radiating without being attached to anything, the theory is you could draw a circle around it and it's pretty omnidirectional. Yeah. The moment you start attaching it to steel structures with a 2-foot face or whatever size your tower might be, that acts as part of the radiator and creates these lobes. If you've never looked it up, look up FM antenna pattern studies, just to get an idea of what they do, how they actually test these with a scale model on the range. Cool. It is pretty cool. It was reassuring for us after looking at 20 different models of where we could mount this antenna. We ended up back in the exact same spot that the current one has been. So we at least know that was a good decision that they made in 1980 when they were planning this project. Here's what I think, though, honestly, about this. In addition to the antenna being, the new one being center fed versus bottom fed, there are some definite advantages to that, more even power distribution among all 6 bays, that kind of thing. Just replacing the transmission line to me is a big deal. Because one thing we know happens over time is that there's a copper, there's copper outside, just inside the coating, a copper ring, and then there's the spindle in the middle that insulates the outside portion from the center conductor, the copper in the middle. Well, we know over time, and lightning strikes and things that happen repeatedly to these things over time, that there are changes that happen inside that transmission line.
Sure.
The insulation breaks down, things start to happen because there's a lot of heat that's released, instantaneously on a lightning strike. I just worry constantly that we're one lightning strike away from a dead short inside the transmission line somewhere. And then now what are you going to do? Yep. So, 30 years of lightning strikes, that's significant. So I think that's as big a part of it really as the antenna replacement. And it ought to be, it literally is as big a part in terms of cost. Like the antenna and the copper costs were virtually identical, which is crazy to think about. But we're pretty excited about this whole thing, and we keep saying it, but we are going to document all these things in video form and put them on our YouTube channel, because these are big time, cool projects with lots of moving parts. And really, it's my first tower reinforcement job like this that we're into, and so I'm pretty excited to share all that along. But we'll definitely keep you updated on these episodes with that as we move forward. And as soon as we get a date on the ultrasound inspection of the anchor rods, we'll do a whole YouTube video, at least one, maybe a couple, on that whole process.
Absolutely. That'll be great. Well, like we said before, we have some plans for upcoming episodes. We're not going to say what those are because I don't know when it's going to happen. But we will have some guests for you and some things coming up. So be on the lookout for that. We appreciate you joining us today. As always, don't forget you can email us at ask@theradiotechguys.com. Thank you to those who have contacted us, even when you're telling us that we're wrong, which we gladly accept.
Yeah, that happens from time to time.
I cry a little and curl up into a ball, but hey, it's okay. No, seriously. Anytime you hear us say something that you question or want to talk about more, please email us. That's what we're here to do, is have the conversation. Don't forget, visit our Facebook, visit our Twitter, visit our YouTube channel. And that's about it. And we will see you next-ish week.
Bye.